notes and then examples. Arc length. Arc length is the length around part of a circle. That's what the word arc means. Arc is indeed part of a circle. So it means it's a fraction of the circumference of the circle. Remember, the circumference measures the distance around, so an arc length would be part of that. How do we measure it? We measure it by how much of a degree measure, how much degree measure the arc has. That is, it's formed by a central angle. And it means that because it's circumference, it would just have regular units, so inches, miles, feet, whatever. And the formula, I'll explain here in a sec. So L, we're using that for the arc length, is equal to the angle. And the angle they're referring to is, well, if I were to draw in a radius and then draw in another radius, that would form a central angle right here. And it would subtend then this arc. And as we know, whatever that is, let's say it's 45 degrees, that's the measure of the arc, that would mean also then that is the measure of the central angle. So the logic is this 45 degrees is out of how much? Well, if we went all the way around in a circle, as we know, that would be 360 degrees, which means we're looking at angle, that is the central angle, divided by 360, which tells us what fraction, how much of that 360, times 2 pi r, which represents the circumference. Pretty straightforward. So the next thing is sector area. Very similar. A sector is part of a circle, and it's particularly the area of that part of the circle. And it means it's a fraction of the area of the circle, and it's formed by a central angle, again, very much like the arc length. It has square units because it is indeed an area. And, well, you've probably eaten pie, the IE version, and that's exactly what a sector looks like. And the formula is very similar. The angle, this would be the central angle again. And out of 360 would give you that fraction. And pi r squared represents the whole area, the area of the whole circle. So once again, we'd have a central angle whose measure would have to be known. So let's say that's the central angle there. And let's say that's 135 degrees. That would mean that this would be what? This area of this sector, forgive my shading, would have to be what fraction of the circle? Well, 135 out of a possible 360 degrees times the area. So here's some examples. Arc length. We know that this is the radius, 11 feet, and this represents the angle. So simply put, you would take 315 divided by 360, which will give you a decimal, times 2 times pi times the radius, which is 11, which would give us 60.5, if you round to the nearest tenth, feet. And that would be the measure of this. Please note that unless the angle is 360 degrees, which wouldn't make sense, that the arc length is always going to be less than the circumference. Same idea, no picture. We assume theta. This is a theta. It's like an x, right? It's just a popular variable for angle measures. That would mean that's the central angle. So it would be 60 out of 360 degrees times 2 times pi times, well, r is radius, 18, which would work out to 18.8 centimeters. That's it. Sector area, very similar, except now we're finding the area of that whole shaded region, which in this case is 135 degrees out of a possible 360, times, but this time because it's an area, it's going to be times pi r squared, or 13 squared. What does that work out to? Right around 199.1, now please don't mess up the units, feet squared, because it is indeed here. The radius is 7. This is the theta, the angle. So 225 out of 360 times pi times 7 squared, which works out to 96.2, and I'm just going to nearest tenth, miles, no good abbreviation. Please don't forget the squared because it is an area. And that's it.